Hello, my name is Eltohami. I'm currently a sophomore here at UNC, majoring in biology with plans to pursue a career in dentistry. I'll be very excited about the opportunity to become a chemistry learning assistant because I've been very interested in the classes I've taken in the past, and with the knowledge and experience I've gained from these courses, I feel like I'd be well suited to help students become more successful and more confident in these classes. Also, as a chemistry learning assistant, I would gain mastery of many concepts, which would reinforce my understanding for more complex classes I plan on taking down the line. As a chemistry ULA, my main goal is to help students find the most effective study strategies and learning habits that are best suited for how they absorb material. I want to help students strategically solve problems and break down hard concepts that are more intimidating to them. Overall, I want to make chemistry less intimidating and more accessible to everyone. I will now show how I would go about explaining one of these problems to students. This problem was obtained from a quiz in our separations unit in analytical chemistry, and it reads, how many 50 milliliter extractions with an organic solvent will it take to remove 95% of a compound X that is in 20 milliliters of water? The partition coefficient that was given for this problem is 0.30. Now the first thing I would want to do, I'm just going to kneel down so it's easier to write, but the first thing I would do for a problem like this is just write the necessary formula that's associated with this problem. And we know that here we have someone talking about Q. So what I'm going to do is write the formula down for Q. Q is equal to V1, which is the volume of the aqueous solvent, over V1 again, plus V2, which is our organic solvent volume, times our partition coefficient, K part. All right, and we're going to put all of this to the power of n, which is the number of extractions, and that's what we're looking for. Now, what I want to do next is just look at all the things that we have that are given to us, and that'll help to plug everything in. So starting here, we have how many 50 milliliter extractions. So we know right away that this is V2. This is what we're doing the extraction with. Next, to remove 95% of solute X. So we know for that, we have to subtract that. We're going to put that in decimals. 1 minus 0.95 is equal to 0.05. So 5% of our original solute X is left after n number of extractions. Next, we have our 20 milliliters of water. That's going to be our V1 value. And then we have our K part. So now what I want to do is just plug everything in. So we know that Q is equal to 0.05. So that's what we're going to set. We're going to set it all equal to that. So 0.05 over V1, which is 20 milliliters, over V1 again, and plus in parentheses 50 times 0.3 K part. All right, and now we're going to raise this all to the power of n, which is what we're looking for. Now the first step that I would like to do is just simplify this, everything that's in the parentheses. And that is going to get us, I'm just going to rewrite the problem down here again. So now we have 0.05 is equal to 0.57. I'm going to raise that to the power of n. Now, our last step for this problem, anytime we're looking for our exponent, we have to raise both sides to the natural log. And once we have it at the natural log, we need to isolate n by itself. In order to do that, we're going to divide the natural log of 0.05 by the natural log of 0.57. So let's go ahead and do that. We have ln 0.05 over ln 0.57 is now equal to n. And if you're confused on how to go about this, just think about for the denominator is always going to be the natural log that is raised to the power of the exponent that we're looking for. Think of it, you have to isolate n by itself. So to isolate n, you're going to divide both sides by this value. All right, and when we put that on our calculator, ln 0.05 divided by ln 0.57, we are going to get 5.33 when you round to the hundredths. Now, the last problem we have here is you can't have a decimal for the number of extractions. It has to be a whole integer. And we can't just have our number of extractions be 5, because that will not get us our Q value of 0.05. So what we're going to have to do here is just round all the way up to 6, because that's the minimum amount of extractions with these volumes. That'll get us a final value of 0.05 solute left. Thank you.